morning everyone. Myself Deepthi, faculty from the Robotics and Automation department. So I am going to have the lecture series on Arduino programming, which is a project-based learning. I am going to explain about an embedded system. In embedded system, so I will be giving an introduction about what is meant by an Arduino and what are the various pins which is available in the Arduino and what is the purpose of various pins and in which pin we have to interface sensors and actuators. So these things I will be explaining in your in an embedded system series. So next in forthcoming lecture section I will be telling about sensors and how to interface sensor with an Arduino board and interface various sensor with an Arduino board and motor and various things and how to build a simple robot by using an Arduino and various projects which is on a hands-on training which is on a project-based learning. So the first thing here will be discussing about a system. So what is meant by a system and what is the general definition for the system. Next, what is an embedded system, what is the difference between your system and an embedded system. Then we'll see about a general block diagram of an embedded system. So what are the various blocks which is associated with an embedded system. And the next is about an architecture which is the architecture which is present in an Arduino UNO, that is an Atmega 238P architecture. Then the detailed things about an Arduino UNO board. So this is a system. The system which is nothing but it is an arrangement, so in which all the units will be assembled together to function in some task, some set of rules. So it will be following some set of rules. For example, here it is an for example we have taken it is an watch. So watch which is nothing but a time displaying system. So this system which has in various components, all the components being assembled together and it has a set of rules to follow to give its output. So here the output is it has to show the time. So it has various components like the needles, the small big second needle and minute needle. So all needle has to function, work together to give its output. It has to show the time. So if any one part gets failed with the system, then the whole part will not work. The whole system will not work. So it is a general purpose embedded system. Next, when coming back to an is a general purpose system. So coming back to an embedded system. So embedded system which is nothing but is a combination of both hardware and software. So you will be having an hardware. So in hardware we will be embedding an software into it. And it might be an independent system or it might be a part of a big system. So a very large system. And usually the embedded system will have it will be an microcontroller based or microprocessor based system which is designed to perform a specific task. The main thing is like general purpose system, it is not designed to perform some specific task. But when coming to an embedded system, the system is designed to perform one specific task, that type of task. So that it is particularly about a particular task and also which has a microcontroller or microprocessor based system. So here they have taken a fire alarm as an example. So it is a fire alarm is a system which gives an alarm when it detects a fire. So it is a specific system. The task is like specific task is to give an alarm when it detects a fire. So it is an examples of embedded systems. So various examples like mobile phones, video games and digital cameras, DVD players and GPS, and these are various examples of an embedded system. So these systems are designed to perform a particular task. It is not for a general purpose system. So it is a basic structure of an embedded system. So initially the basic structure, it is an, if you can say, like block diagram of your embedded system structure. So you will be having a sensor and you have an actuator, and the main part here is like processor or it might be a controller or anything. So the processor has to perform the things. So what it has to be done. So if you haven't taken an embedded system, so what your embedded system has to do to be done, it's been done by decided by your processor. So we have to write the code in a processor. So before that, so in embedded system we'll be having a various sensor and actuators. So we need to interface a sensor with a processor. So the processor will accept only, and it is a digital system, so it will be accepting only in zeros and ones. But when coming back to a sensor, will be having a more analog sensor as well as a digital sensor. So if it is an analog sensor, we need to have the block which is an analog to digital converter, where your sensor's analog data will get converted into your digital data, so that your processor can process your digital data After processing, the processor will give only a digital data. So when you need to actuate some actuator, you need a signal. It is not a digital signal. So you need some then analog signal, analog voltage to actuate your actuators. So in that case, you need a digital to analog converter where you need to convert your processor output digital data into an analog data. That analog value will trigger your actuator to run. So this is a basic block diagrams of your embedded system. So in between you will be having a memory where your processor to store your data and the processor to retrieve the data from some stored devices. So you have the memory. So this memory can have the access to your so you can get the data from in sensors, and those data can be stored in a memory. After processing, data also can be stored in a memory. So processed data also can be stored in a memory. So far we have been discussed about what is the basic structure and block diagram of an embedded system and various units functionalities which is in an embedded system basic structure. So the next series I will be discussing about what is this processor and what is the processor, what is the purpose of the processor in an embedded system. So we will meet in next series.